I'm Kevin Elmy. In this presentation, we're going to go through the five basic soil health principles that I follow. Right now, soil health is a hot topic. People, different groups are talking about it. Different people are talking about it. And everybody has their thoughts and beliefs of what is right. But right now, our farm margins are fairly tight. Input costs are going higher. We're seeing more and more problems in our production systems. And with today's thinking, well, we keep thinking that we have this solution we could just go and buy. So a solution in a bag or solution in a jug, and not quite that simple. Because when we come to soil health, when we start talking about improving soil, what do we actually mean? And in a lot of cases, what we're trying to do is increase our organic matter. We want to get more carbon back into that soil. We want to decrease the amount of pests that we see in our fields, in our crops. We want to see an increase in our water and rain use efficiencies. So not only using that water more efficiently, but the water that hits the ground, where does it go? Does it run off or does it actually get into our soil? And we want to see an increase in fertilizer use efficiencies, which will then drive down our fertilizer use. So the five main principles that I work on when I'm talking about soil health is number one is keeping a living root in the soil for as many days as possible, and preferably in the vegetative stage. Number two is reducing the amount of tillage we do. And by reducing tillage, we're going to maintain our soil armor on the soil surface. Number three, we will want to reduce the amount of synthetics. So our herbicides, our fungicides, our insecticides, and the fertilizer. Number four is we want to increase our plant diversity, both in our rotation and throughout that growing season in that year. And number five, we want to have some livestock integration. So the first one, the living root throughout the year, to me, this is the most important piece in soil health, because when a plant is in the vegetative stage, it will release up to 80% of the carbon that it sequesters through photosynthesis back into the soil as root exudates. These root exudates will feed the soil microbes, which sounds crazy because why is the plant giving up all of these nutrients? And what's happening is when those root exudates hit that soil, that that is feeding the biology. The soil biology is then going to go out and find and develop these nutrients for that plant for the rest of its growth period. When a plant enters the reproductive stage of its life, the root exudates drop dramatically. And that's because the energy and nutrients, instead of going into the soil, need to be used in growth and into grain and seed production. So those root exudates, when we have something in the vegetative stage, is going to keep that micropopulation in the soil active and fed. So it's going to continue releasing nutrients and finding nutrients for that plant. So that growing root is really important because when we start talking about mycorrhizae fungi, it needs a host. And that host, when that root is pushing through that soil, the the active layer or area of where the a lot of the action is happening in the root system is right at the root tip. So every time that root tip keeps pushing through the soil, we need to have that root tip reinfected with more mycorrhizae. So the more we have that green growing plant with root exudates that's pushing through the soil, the more opportunity we're going to have for the mycorrhizae to spores to germinate and infect that plant and keep this whole process going. Because the mycorrhizae fungi will act as extra roots for that plant. The mycorrhizae, they produce a lot of glomalin in the soil, which is a glue that creates soil structure. And in that soil structure, this is a place where now we start seeing more soil carbon being secured, sequestered, and stored safely. And this is one of the neat things with the soil health. When we see soil increase in soil health, we're going to see an increase in organic matter. We're going to see an increase in soil carbon. When we start looking at this picture that's on the screen, and you see those roots, and they're completely covered in soil, those root exudates come out of the root. They they attract that bacteria, and the bacteria, they want a home, so they will create this soil aggregation. So when you see roots like this, that means we have things happening properly, and we're going to start seeing some good steps forward on our soil health. Reducing tillage. Zero till has been a very positive thing for agriculture because it has slowed down the loss of organic matter from our soils. It doesn't necessarily increase our soil carbon in our soils. It basically reduces the losses. In through history, through testing, zero till has shown some increases in organic matter since the days of summer following. But we're going to get to the point where, number one, it's not very fast. Number two, we're going to start hitting some ceilings. When we start talking about tillage aerates that soil. When you're aerating the soil, that's going to promote and stimulate bacteria populations. It's also going to damage your fungal populations. When tillage happens, that will actually start burning off organic matter from the soil. And this is the reason why we saw organic matter levels drop during the years of high tillage. So that bacteria will get in there and they'll start, eating the plant material, the root exudates. And when our carbon nitrogen ratio starts getting too far out, all of a sudden, it needs a carbon source. So then it starts eating the organic matter in the soil, which then it starts dropping. When the carbon starts leaving the soil, this is when we start losing things like soil aggregation. This is when we start seeing uh, water sitting on the surface. We don't have that infiltration. That's when we start seeing these issues. As the fungal populations keeps dropping from tillage and the bacteria populations keep increasing, our fungal to bacteria ratio is falling. When that falls, especially below zero point 0.3, that is regarded as that soil being bacterially dominated. When we look at bacterially dominated soils, those soils are addicted to inputs. They need to be fed all the time, whether it is fertilizer, whether it's herbicides, whether it's fungicides, all of these issues. Once we start balancing out our fungal to bacteria ratios, a lot of those issues disappear. So these bacterial based soils, what you'll see in it is poor aggregation. You'll see low water infiltration. You'll see high erodibility. You'll see high requirements of fertilizer, herbicides, and fungicides, and you'll see poor tilth. This picture, I was driving into Yorkton, and I had to really slow down, pull off to the side of the road because I could not see the road. The soil was getting blown away. The really sad part is this light fraction is extremely important on your soil health. So we need to keep that where it should be, and that's in the soil. So by reducing the tillage, it will allow better soil armor. And that soil armor is basically that old plant material that's laying on the surface. That's going to protect the soil against erosion, evaporation, and extremes in temperature fluctuations. So that when we see a field, once again, like this field, where it's black when the sun's out, it's going to be spiking on temperature. If it gets cold, it's going to start dropping. Those microbes do not like those big changes, so we want to protect those microbes against these wild fluctuations in temperature. Never mind the evaporation and the erosion. Reduction of synthetics. So once again, the bacterial dominated soils are addicted to these inputs. When we start adding fertilizer to the soil, that outsources jobs that the microbes in the soil they normally do. By adding herbicides, that temporarily, or maybe a little longer than that, changes the microbial populations in that soil. The thing we need to look at is when we start talking about weeds, we have to identify them as early successional plants. These weeds or early successional plants are telling us what's going on in our soil. So these are our eyes that we don't actually have to go in and look in the soil to see what's happening. So when we see weeds like red root pigweed or lamb's quarters. That tells us that we have a high nitrate load in our soil, and we have to figure out a way to tie up that nitrate. Once again, bacterial soils will produce high nitrates. Nitrates in the soils will produce weeds. How do we get around that? When we are looking at reducing these synthetics, we just can't cut ourselves off cold turkey. We have to earn the right to reduce these synthetics. When we're talking about fertilizer, what are we doing for nitrogen fixation? Do we have a legume in rotation? Are we intercropping? When we're looking at the use of herbicides, what weeds are growing, why they're growing? Is it thistles? Is it each one of these weeds are telling us what the problem is, and we have to learn how to adapt our management to make sure that we can earn the right to get away from adding those synthetics. When we start talking about fungicides, using fungicides on our crop will continue to entrench our soils to stay in that bacterially dominated state in our soils. The residues of fungicides, whether it's through the plant residues or the root exudates, will negatively affect our soil fungal populations. So when we have that trash, so we spray fungicide on our crop and we have this crop residue, we put it back into the soil. If there is fungicide in that straw, when it hits the soil, we need a fungi to come in there and break it down, because you're dealing with a lot of lignins, a lot of complex carbon chains in there, and that's where the fungi they shine. If there's a fungicide in it, the fungicide won't allow the fungi to get in there to break it down. So now we have a straw management issue. When we don't have this nutrient, this breakdown of the straw, now we're dealing with nutrient cycling. Now we have, mycorrhizal populations being damaged because of this fungicide getting back into that soil. So in my mind, when we're talking about, reducing synthetics and we want to build fungi, it kind of seems necessary to one of the first things we should be looking at is getting rid of fungicides out of our management systems. Increasing plant diversity. When we start talking about plant diversity, the things we want to be looking at is using different functional plant groups, because these different functional plant groups have different ecological advantages in in our world. Each one of them has a reason why they grow. Each one of these functional plant groups, and could even change from species to species within the group, will have different signature of root exudates being released into the soil to support different kinds of soil microbes in the soil. So the key is to use as many functional plant groups as possible to build that microbe soil microbe population complexity in our system. When we start getting that, the rest of it starts falling into place. And this is where Dr. Christine Jones, she talks about the microbe quorum. And this is basically, once we start getting 6 to 9 species in these mixes, this is when the magic of when we start seeing some big jumps in both production and soil health. So what do I mean by functional plant groups? I've broke it down. I started out with one triangle, and so I talk about grasses, legumes, and broadleaf. The deeper I got into it, I broke that broadleaf into 3 more subgroups. So we're talking about brassicas, non-brassicas, and forbs. So we'll have 5 main functional plant groups that I work on. And where do we get the diversity? Now we can start talking about warm and cool season species of each of these. We can talk about annual, biennial, and perennial species of within each one of those. This is where we get the diversity. So when we are looking at a blend of silage, and we say, we have 3 functional plant groups, we have oats, we have barley, and we have wheat. In reality, those are 3 cool season grasses. Roots are slightly different, growth stages slightly different, but it really doesn't add much to the diversity to that blend. So we really need to, when we start looking at it, how many of these can we check off in our mixtures? When we're talking about cash cropping, now we're going to start talking about doing intercropping or relay cover cropping. And once again, we want to mix up, have that legume as that nitrogen source, have that grass as your grain or your biomass, your brassicas, your non-brassicas. For we want to incorporate those. And when we look at diversity, not only do we have to think above ground, but also think about what's happening below the ground. When we have these mixes, what what is the height of each one of these plants? We have a short, medium, and tall. When does it gain height? So is it a biennial? So the year one it stays really short, and year two is when it starts taking off for height. How long does it take before it gets into that reproductive stage? Something like buckwheat will shoot up really quick, whereas something like pearl millet will stay lower for a longer period of time. Are we dealing with a fibrous root system or a tap root? Are we dealing with a deep root system or a shallow root system? Are we dealing with mycorrhizal plants or non-mycorrhizal plants? And if it's a non-mycorrhizal plant, do we have something in that soil that's going to help support the mycorrhizae? So in this case, canola is non-mycorrhizal. When we throw peas in with it, now we have a mycorrhizal plant that will support that mycorrhizae through that year of growing canola. Here's just a quick picture from Cotswold seeds from England to give you just another view of what some of these roots will do. You know, where how high does it grow? What the roots go down? Is it fibrous? Is it taproot? This is the diversity we need to be looking for. When we are looking for this plant diversity, it doesn't necessarily mean we need that complete diversity every year. But think of your rotation. Think of the different times of the year. So, is there a time where we're growing fibrous fibrous root system? Is there a way that we can be seeding something in the fall, like a radish, that's going to drill down with a deep taproot? A number of ways of getting this done: relay cover crop, fall seeding, intercropping. That relay cover cropping is where we'll introduce a a, a next set of plants that are going to grow into a cash crop, that when we take the cash crop off it, that relay cover crop will continue growing into the fall, into freeze up, and maybe into next year if that's what your goals are. Including livestock. Mixed farms across the Canadian prairies have almost disappeared. Today, farms are very specialized producers. They hang their hats on, this is what we pride ourselves on growing. But there's an opportunity to partner with a local livestock producer. That's if you do not want to own your own animals. The livestock producer, this is what they specialize in. They do a bang on job of it. This is an opportunity for a straight grain farmer to have livestock integration into their farm without having to own, without having to, really understand the animal production side, but still get the benefit of having those animals on the land. Because when we look at our soils were developed over centuries of this wildlife plant relationship. Plants were growing, animals, grazing animals come in huge herds. They graze, they drop the manure, they drop their urine, and do the trampling, and then they're gone. Then they come back. This is how our soils were developed. And when we start taking the animals off and we replace, once again, outsourcing the jobs, this is where our soils are starting to get into trouble. The Some of the other advantages of having this livestock integration, it allows new income stream. So that this way, when there's snow on the ground and there's no crop to be grown or harvested, at least the residue that is there is going to be utilized, and there's the potential of getting paid to get that done for you and have the animals out there. This also helps reduce tillage, so that this way, if there's a bunch of oat straw on the ground, the animals are going to go through, because the ruminants, they'll be able to go in and they'll be able to graze that off, help reduce that residue, so that this way you don't have to go out and either bale, burn, or diss that residue back in. When we start reducing that tillage, that also once again doesn't drive that nitrate spike, so that this way we're not going to get that flush of weeds, that early successional plants. As long as in the spring we have some way of managing that next flush of nitrate release in the spring to create a new weed flush in the spring. So that's a brand new topic to get into. The other neat thing is when we start throwing the animals out there, that starts importing a lot of nutrients. It cycles nutrients through that manure and urine. When we look at those five principles, do you need to check all five of those off and say, yes, I'm 100% on the regenerative ag or their soil health? No. And this is what a lot of people get intimidated with is, you know, where do I start? What do I do? What do I have to do? And it all goes back to what your goals are. If your goals are to, reduce tillage, okay, well, zero till, buying the right tools for the right job, you're there. To get on to improving and repairing our soils, we need to be checking off as many boxes as possible. Each farm will develop their own execution plan of what they want to do. You may have, different goals, different assets, different restraints. And once we get into this, the real exciting part of it is if if you enjoy this, is now we can start breaking down the farm. So now we're going to have some places with different topography. So something that's flat versus that's rolly or hilly. We're going to have something that is sandy versus clay. We're going to have something that there's no a water source, so we can't get the livestock on there. But how do we manage this? And this whole game plan. There is no cookie cutter approach to this. We have to go through and develop a system, and you can either call them failures, or you can call them a learning opportunity. Now it's a mistake if you do it the second time, if you make the same mistake twice, which once again, yes, I make mistakes on our operation, and once again it's a learning opportunity. Okay, just because it didn't work the first time, why didn't it work? We need to understand why it didn't work. So, well, it didn't work because this relay cover crop broadcasted after our wheat was established, and we got no rain all summer. Well, that wasn't the problem of the management. It was an external source of air. So we just have to, okay, so how do we adapt? So is it that no rain going to happen again, or are we going to go the other extreme where we get flooding? And so then how do we then adapt to that? So these soil health principles, the things we need to do on the farm is number one, get out there and dig. Find out what's underneath your foot. What are you farming? Are you farming 5 centimeters of topsoil, or are you farming 50 centimeters of topsoil? What does your soil structure look like? What are your plant roots doing? Are your plant roots going down 5 centimeters, hitting a hard pan, and then going sideways? How do we fix it? What do we have to do? Observe your plant growth. What weeds are growing? The weeds growing is one of the things that we really need to understand. That when we see certain weeds, it's telling us that these conditions are in the soil and we have to fix them. Not just keep going out and spraying, because if spraying was effective, then why do we still have wild oats even though we've been spraying wild oat spray for 50 or 60 years? It's a condition in the soil that those weeds are trying to fix, and we are missing the point. The other thing I really like taking a look at is what wildlife do you see in the area? Do you see an increase in sharp-tailed grouse population, deer population, jackrabbits? What are you seeing for wildlife species? How many species do you see? The other one is continue learning. Lots of good videos out there. There's conferences. There's bunch of fabulous books to read, and also talk to other producers. See what they're doing. How are they doing it? And what are they seeing? what and not just, oh, okay, so you know uh, neighbor is doing this, and he says it's working, so it's going to work for me. Well, maybe he's just a livestock producer, not just, but he's a livestock producer with livestock integration on everything, and your operation doesn't have any livestock, doesn't want to have livestock. How does that transfer from one farm to the other? So, find out what their goals are, what they're doing, how they're doing it. Get a lot. There's really good information out there. So if you have any questions, here's contact information, and hope you enjoyed it.